Good morning. Now we are going to see assignment number 8 of NPTEL. Now in this we have first question statement A, the method of constant deformation is a displacement method. So this is wrong statement. So we have displacement method, that is stiffness method. Second, we have the method of consist deformation uses compatibility equation to find structure. Yes, we are going to use compatibility equations along with equilibrium equations to analyze indeterminate structure by using method of constant deformation. So we have option is B. Now we have a problem on the same, that is method of consistent, or we are going to use compatibility equation. What compatibility equation we are going to use? So now you can see what will be final displacement at B. So delta B should be equal to 0. That is in vertical direction. So we have displacement in vertical direction is 0. So whatever displacement will be developed by this UDL will be managed by the displacement of the reaction RB. So now you can see we are going to use two separate. So we are saying that is displacement due to UDL in vertical direction is downward, and displacement due to reaction RB, that is in vertically upward direction. But we should have final displacement should be 0. So now you can see this. So we have this. We have removed B and we are considering determinate structure. So now as we have UDL, so our BMD have parabola. So we have this is x to the power 2 in UDL. Now, what will be my bending moment? 4 into 2, 8. It will act at center. So 4 into 2 equal to 8. And then 1 meter from this. So bending moment I will get 8. So this will be bending moment diagram. If I will divide it by EI, so it will be M by EI diagram. And if I will use this as fixed, free becomes fixed, fixed becomes free. So this becomes my conjugate beam. And this is in downward direction. So we are going to get, due to this, delta B, and that we will get, I will say as 1, which will be equal to, now we have this will be minus, because displacement is downward direction, and what will be, we have to take moment about this, we have to consider total area of this. What will be total area? So we have 1/3 into 8 upon EI into 2, and where it will act? It will act at 3/4 of 2 from 0. And then delta B1 we will have 1 by 3 into 8 upon EI into 2 into 3 by 4 into 2. Now these 2 2s of 4 gets cancelled, 3 gets cancelled, and we have delta B1 minus 8 upon EI. Now we are going to remove the load and then we are going to apply reaction. So you can see this. We have applied reaction RB. Now what will be bending moment diagram due to this? So we are going to be in this fashion. Then what will be bending moment? Now this will be considered as load. Now we are not considering this as reaction. This will be considered as a load. So what will be bending moment over here? So we have 2 into RB. Due to concentrated load, RB considered as concentrated load. And if I will say M by EI diagram, so divided by E, Now, if we will go for conjugate, we will consider this as fixed. And now we have this will be displacement in upward direction. And now we will have this moment about B, and then from this we will get delta B2. Now what will be total area? So we are going to get total area that will be 1/2 into base into height. We have 2 RB upon EI, and where it will act? So it will act at 2/3 of 2. And then we will have delta B2, I will write below. So delta B2 equal to 1/2 plus into 2 into 2 RB upon EI into 2/3 of 2. Now see, we have one get cancelled, and delta B2 we will get it as 8 upon 3 EI. Now we know total displacement at B should be 0. So we have delta B1 plus delta B2 equal to 0. So minus 8 upon EI plus 8 by 3. So this will be RB is there. So we have 2 RB. So RB into, so 8 by 3 RB upon EI, and that is equal to 0. And from this we will get 8 by 3 RB upon EI, which is equal to 8 upon EI. So EI gets cancelled, 8 gets cancelled, and we will get therefore RB equal to 3 kilonewton. And as value is plus, we have assumed upward. So we have 3 kilonewton. So option we have B. Now we will go to the third problem. So in this, we have this calculate the horizontal reaction at support B. Now you can see this is indeterminate truss because we have two reactions over here. We have two reactions over here. So we have four reactions. So it is indeterminate. Now as it is we have in question reaction force at support B horizontal. So we will consider this HB, this is redundant. So we will remove is a redundant and we will find P forces. So we have this as 25, this will be diagram. Now you can see we have this as C point. If I will apply summation Fx0 at C point, so if I will consider C point and forces over here, so we have this as 25 kilonewton. And then this will be FCA. And if we apply summation Fx equal to 0, then we have, let us this angle, we have theta, need not required to calculate. So we have minus FCA. Horizontal, we are sine theta, which is equal to 0. And therefore, we will get FCA that is equal to 0. So we have force in this member 0. As this is 0, so automatically by considering this joint, which is B, no horizontal, so this is 0. And then we have force in this member that is 25 kilonewton, which will be compressive. Then we will apply unit force at A, and then we will find the forces. So now we know, as we have this as joint, and we do not have any load over here, so both these are 0. And then we have this will be 1 kilonewton or 1. Now, as we do not have forces in CA and AB, these are P forces. And K we have only in AB, but P we do not have in AB. So if you go to the equation, so we have dq is equal to dql plus F into Q. Now dq, this is final displacement. Final displacement. In most of the case, we have dq equal to 0. What is dql? So we have dql. This is displacement due to loads. And we are going to calculate it by using summation pkl upon AE. And then what will be F? So we have F that is equal to summation K square L upon AE. So we have these values. Now in this PKL becomes 0. K square L upon AE, we will get it as 3 upon EI. But Q we are going to get 0. And therefore we have force reaction that is HB equal to 0. So we will get value of HB that is equal to 0, because now if we will put 0 in this equation, if we will put 0, dql, pkl upon A, we have 0 plus k square L, k is 1 in this only. So L we have 3, so plus 3 upon EI, and then AE into Q. Q we have that is reaction HB. Sorry, force in, yes, we have considered HB as redundant. So we will get this as reaction HB. And then we have equal, therefore, Q that is equal to 0. So HB as redundant. So HB is 0. So we have option that is A. So likewise, we have to solve the problems related with your assignment number 8. This will be first part. Now we will stop here only. Thank you.